Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in wireless sensor networks. We're going to see the applications of wireless sensor networks, right? We're going to see applications and as well as deployment of sensors for different applications, right? We've already seen the applications of wireless sensor networks in the first video. We have just given the overview of different applications. Today we're going to see what are the different sensors that is used for different applications and what are the different applications that has been where WSN has been implemented, right? So we'll start with applications of wireless sensor networks, right? So right now in almost all fields we will use WSN. That is, WSN is implemented in almost all fields, right? That is in military application, habitat monitoring, health application, environment monitoring, home application, industry application, traffic and automatic applications, intrusion detection, underground, underwater analysis. In almost all fields we are using WSN, right? So all these are we have already seen, right? In agriculture, for smart agriculture, for crop monitoring, right? So for proper pesticide and for proper irrigation, right? For monitoring the crops, wireless sensor networks is used. And for natural disaster, right? For monitoring forest fires, volcanoes, right? And even any disaster condition, and in order to monitor wild animals, fauna applications, right? And even industry application, radio sensor network to monitor the radiation which is emitted from the industry, right? And intrusion detection, military application in order to in battlefields or in borders, we can able to use sensors for intrusion detection, right? And smart cities, this is very important right now. Smart cities plays a vital application where if we speak about smart cities, right, you should have smart parking, right, smart transportation system, right, and intelligent home automation system. Everything comes in smart cities, and you can able to implement all these applications in WSN, right? And most importantly, healthcare application after COVID, right? Lot of sensors has evolved for monitoring the patients. That is, non-invasive monitoring has been emerged. That is, without touching the patient, we can able to monitor the body parameters, right? So all these are various applications of WSN which we have already seen, right? As I said, it is implemented in almost all fields: environmental, flora and fauna, industry, urban, military, health, all the fields, correct? Right. So what are the different sensors are in detail to see detail about this WSN? We will just take health application. We just said about health application, right? But you can see a lot of sensors where you can use motion sensor, temperature sensor, biomedical sensor, position sensor, seismic sensor, humidity sensors, right? RF sensors. All this can be possible, right? All the sensors can be used, right? Predominantly, when you say health application, three different application is possible. One is by using wearables, right? We can able to use wearable devices, right? Wearable wireless devices, right? That will predominantly give you the information. Right now, even a smart watch can give you your heart rate, your temperature, and all those things, correct? Right? So we can able to monitor patients, right, using this wearable. That is one particular application. Another thing is home assisting, right? We can right now, after COVID-19, the home assisting systems has emerged a lot, right? Where online diagnosis, remote diagnosis is also possible, right? We can able to get all the parameters, the important parameters to diagnose patient remotely, right? By using this sensor networks, right? And also very importantly, in hospitals, we can able to do patient monitoring, right? That is healthcare facilities, right? In hospitals, right, we can able to monitor patients invasively. We can collect the informations, right? And also you can use radars and all those things to monitor patient movement as well. You have motion sensor, RF sensors as well to monitor patients very accurately, right? These are the applications of wireless sensor networks in health domain, right? And similarly, in environmental application, you have water monitoring, air monitoring, and emergency cases. That is during smoke, forest fires, volcano, etc. Right? Similarly, you have a lot of sensors, gas sensors, water sensors, humidity sensors, smoke sensors, temperature sensors. All these are used for environmental applications. And when you said about environmental application, you want to speak about water monitoring, air monitoring, and emergency alert as well, right? If it is water monitoring, there is one particular system which is called as cyber physical system, which can be implemented, right, to monitor the water, right? What it can do is it can provide a lot of information about water demand or water quality, right? And it provides also some repair information, right? If there is any leakage in the pipe, right? There is any weak spots in the pipe, everything can be done using this particular system by using WSN sensor, different sensors and RFIDs. That is possible. And air monitoring, right? We know that we have different sensors, right, to measure the quality of air, right? That can be done, and the action can be taken depending upon the sensor values. And similarly, in any particular disasters like volcanic activity or forest fires, right? So this sensor networks can be used to sense those information, right? And we can create an alert system, right? So that we can rescue more people or we can prevent those disasters, right? This is about environmental application. And flora and fauna, we have already seen that, right? For crop monitoring, livestock farming, greenhouse monitoring, right? Mostly in agriculture field, you can able to use, right, the same different sensors, conductivity sensors, photographic sensors, gas sensors, right? Even motion sensors to monitor the livestocks, right? So all this can be possible using wireless sensor networks, right? That is, we can able to implement this sensor in agricultural field where we can able to do crop monitoring, right? We can able to find out the humidity level. Depending upon that, the irrigation can take place. We can continuously monitor the crop growth, right? And if there is any fertilizers needed or any pesticides needed, we can able to do it, right? So this is completely useful in agricultural field, and it has already been implemented as well in most of the places. They started using sensor networks in agricultural field, right? And industry application, once again, industry application is very vital role where the sensor networks can provide monitor and control applications. It can be used in logistics to find out where the exact packages is. It can be used in robots, right, to understand the movement of a robot, and all those things can be done. And similarly, machinery health monitoring, we can able to monitor the machine health, right? We can able to understand how long the machine can work, what is the lifetime of that work, if there any repair is going to happen, if there is any weak spots that is in the machinery, that is possible using wireless sensor networks, right? So that is the explanation which is given here. You can see robot can incorporate major problems in sensor nodes like redeployment, traveling, etc. Similarly, in machinery health, right, we can able to monitor machines, right, and we can able to find out, we can able to provide a solution, or we can take remedial action for it, right? Even not only in machinery health, we can also deploy sensor to monitor building, structure building, as well as bridges, right? Right now, a lot of bridge accidents takes place, right? Like bridges which is there for more long years, right? That is getting destroyed by itself, right? To prevent those accidents, we can monitor those bridges using wireless sensor networks very accurately, because right now we have only human monitoring. You have a lot of real-time monitoring is mostly based upon human monitoring, right? That is why a lot of actions takes place. But if it is wireless sensors networks implemented, we can able to monitor, we can able to get the exact information about the lifetime of the bridge, right? And where is the weak spot, right? What is the damage, where is the damage, everything can be done, right? So this is about industrial application, about and as well as structural application, right? And urban application, as I said before, we got to speak about smart homes, smart cities, transportation system, structural health monitoring, which I just said, to monitor the lifetime of the building or bridges, all those things. And apart from it, we can able to create a smart city or smart homes, right, by providing smart transportation, providing parking system, right? Home automation is possible, right? An automated parking system that is possible. Everything can be done using all the sensors, right? Pressure sensor, visual sensor, acoustic sensor, accelerometers, right? Motion sensors, all the sensors can be implemented for urban applications, right? So whatever I said, that is given as notes here, correct? So this is about different applications of WSN. But for all this application, deployment of sensors is very important, right? So what is deployment of sensor? How to create a sensor network for these applications? How to deploy WSN for all this application? That is very important, correct? Right. So in that case, sensor deployment. When you speak about sensor deployment, right? There are three types of deployment is possible. One is static deployment, random deployment, and as well as dynamic deployment, right? So what is static deployment? This is static deployment, right? What is static deployment? It can be done in two-dimensional way or three-dimensional way, right? Static deployment can be used only if we know the exact location of the sensor, right? If we can able to determine the exact location of the sensor, where the network has to be created, right? It can be a normal application, right, where a sensor network can be created. If we can able to analyze the exact location, or if we can able to create an exact network, right, an exact location of the sensor, then we can use static deployment. As I said, it can be done in two-dimensional as well as three-dimensional, and it can also be called as deterministic deployment. It can be called as deterministic deployment, right? And what is random deployment? Random deployment, as I said before in challenges itself, random deployment in military application, we cannot go ahead and create a network in the battlefield, right? In that case, what we have to do is we have to do a random deployment. We have to just throw the sensors so that the sensors will create a network by itself, right? So randomly we throw the sensors. That is called as random deployment, where it will be implemented whenever we don't know the exact location of the sensor, where to create the sensor network. If the location of the sensor is undetermined, right, then we go for random deployment. You can see here there is no preferred structure for it. That is a random deployment, correct? But in random deployment, you have a lot of challenges, right? The sensor network, most of the sensor network may not be able to work, right? It has to overcome a lot of failures, right? And it has to self-manage itself. All those challenges is possible in random deployment, right? And then there is something called dynamic deployment. What is dynamic deployment? That is, it is just the combination. That is, in dynamic deployment also, the sensor networks will be thrown randomly, right? First, it will be done, random deployment will be done, right? But after that, what will happen? After the sensor network falls on that particular area, right? This sensor network, right, will change its location by itself. That is, it will change the location because it will not be able to receive the signal properly, or it will not be able to communicate properly. So what it will do is, after reaching that particular place, it will change its location by itself, right? That is called as dynamic deployment, correct? So this, for this dynamic deployment, there can be, it can be done by two things. One is central deployment, and then distributed deployment. That is, there can be two configurations in this dynamic deployment. For central configuration, in the sense that there will be a central node, that is, zinc will be a powerful device where that zinc will find out the location for each and every sensor, the accurate location, and then it will then send that information to the sensor to move that to that particular location. The zinc will take the control of everything, right? It will find out the location for all those sensors, right? After deployment, then the central node has to function very actively, and that is called as central configuration in dynamic deployment, right? In distributed configuration, what will happen is, the zinc will not play a vital role. All the sensors by itself will find out the exact location where it receives the proper signal, where it can be able to communicate, right? So it will change its location. That is called as distributed distribution configuration, right? So in sensor deployment, you got to speak about static, dynamic, and as well as random deployment. In dynamic deployment, you got to speak about central configuration and distributed configuration, correct? Right. So today what we have seen is, we have seen about applications of wireless sensor networks, right, where We have seen variety of applications, what are the different sensors used, and at last we have seen deployment of sensors for each and every application. Correct? Thank you, students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.